we got a chance to talk a little bit about the opportunities for copper nanowires and how they compared with other technologies that were out there. And it took me a very short period of time to realize that this was an extraordinary new opportunity.
So we're in the basement of the French Science Building at Duke University, and we're with a couple of brilliant minds who are behind a very cool startup here called NanoForge. The research came out of Duke University, and Steve, tell us about the genesis of this and how you guys got together.
About a year and a half ago, I was approached by Duke University. I'd been doing some work on helping start up new companies in the area here, and was introduced to Ben here as a potential startup opportunity coming out of Duke in this area of nanotechnology. We got a chance to talk a little bit about the opportunities for copper nanowires and how they compared with other technologies that were out there, and it took me a very short period of time to realize that this was an extraordinary new opportunity. And the opportunity to work with Ben here was just very unique. And so the two of us decided to form a company together, and we licensed the technology out of Duke about November of last year and formed the company. Very quickly figured out how to convert what was here in the lab into something that was actually practical for scale-up. And within about, I'd say, 4 or 5 months of forming the company, we're already starting to sample the product in the marketplace.
So Ben, you were doing research on your PhD program up at University of Washington, also in nanowires. You've been here 2 years, and then you came across this particular recipe, if you will. Walk us through the recipe and how you came across it.
Sure. Well, being familiar as I was with the use of silver nanowires in transparent conducting films, I thought, well, wouldn't that be great to use copper, since it's 100 times cheaper and nearly as conductive? So I came across this recipe. Fortunately, people had figured out how to make copper nanowires. And the process they use is basically you take a copper salt, like instead of sodium chloride, it might be like copper chloride or copper nitrate. You mix that in aqueous or water-based lye solution. You add some hydrazine. It's used for rocket fuel. Here we use it to reduce the copper ions to copper atoms. And then we have a molecule we add called ethylene diamine, which causes the copper atoms to assemble in solution over the course of 20 minutes to form nanowires. Why it happens in this way is not completely understood. So there is a bit of trial and error involved to find the right conditions. And although we did start with a published recipe, we found it didn't give us wires that we needed to get the properties or specifications we needed in the transparent conducting films. So we had to do some modification of the recipe, allowed us to get wires that were twice as long, half as thin, and very well dispersed, so that we could easily coat them and spread them across a surface.
So, Steve, we've heard from Ben that we're not quite sure how this happens. Talk to us about what the value propositions are with this particular approach.
Sure. What is so exciting about the whole concept around nanowires is the fundamental usage in products to make transparent conductive surfaces. So we talk about what's called a TC, or transparent conductive layer. What ends up happening is you take the nanowires and you just spread them out in a film, in a kind of an ink, and they lay down just like toothpicks do on a surface. And so what ends up happening is you get this wonderful random pattern, which is nearly transparent and can actually be electrically conductive. That surface ends up getting used in every flat panel display, every solar cell, every cell phone, touch panels. There's just this, every application that you see in the world that has some kind of light electrical interaction on a flat surface has a transparent conductive layer. When Ben came to me and said, look, I can do this. I can produce this surface that is, as transparent, meets exactly the same specifications that the market has right now for indium tin oxide. And I can show it you in my lab right now. And it's going to be, as a material, it's 100 times cheaper at a minimum, and our process for making it is so much simpler. That is a formula for success. I mean, that's why you start companies, is because the demonstration was right there in front of me. We could see it in the lab. It wasn't like it was going to take us another year or two to figure out that this was going to work or not.
So you've worked with a lot of startups, but you've never worked with one in which the technology came out of the university. Walk us through what that's like.
Fundamentally, developing a really good relationship with the university is key to being successful here. Bottom line, without having someone like Ben, who is committed to wanting to see this technology actually be commercialized, it's very difficult, if not impossible. And then the relationship with the university, in particular the licensing offices and the surrounding organizations, is also critical. I mean, having that relationship such that they know that that everybody's on the same side, that we're all trying to get a technology out, that a startup company is actually the most appropriate way, rather than potentially licensing it to a particular university, a particular customer, or something like that. In reality, Duke has been remarkably supportive in terms of trying to get this technology out. I think everyone involved has seen how exciting it can be, because it's something real. We actually have something from the lab that actually works. And that doesn't happen in university settings ever. Okay, this is just not something that happens very often.
So I noticed this little art here, which is kind of a pirate ship on wheels. Is there any significance to that, or somebody was waiting for something to anneal or something and was just killing time? What's going on there?
That might have started out as a chemical formula, but then it kind of self-assembled into evolved into a piratical ship. Maybe this will be us taking over the ITO industry or something like that.
I love it. That's great.